But we are going to prove trig identities. This is section 7.3. Now, when we prove trig identities, there's a couple of different things we can do. There's basically two methods. You can work on one side of the equation only, or you can work on both sides of the equation, but you can't cross the equal sign. We're trying to prove that one side equals the other side. Usually you start with the more complicated side, and when you have the option, rewrite things in terms of sine and cosine. Rewrite in terms of sine and cosine, if that's an option. That's usually a good place to start. There is often not one correct way to do it, so most of these I will probably take up and look at because there's more than one way to do it correctly. Ross, sit up, please. You probably want to take notes. So what I want to do first is I've got 1 plus the sine of 2 theta. And I want to prove that that equals the sine of theta plus the cosine of theta squared. Now remember, we cannot cross the equal sign, so what I usually like to do is draw a line to remind me I can't add or subtract from both sides, I can't multiply on both sides. I'm going to work on one side or the other. And in this case, you've got options. You could probably rewrite the sine of 2 theta, but I'm going to work with sine plus cosine squared. So remember, here we're just going to basically FOIL this. This becomes sine squared theta plus twice the sine theta cosine theta plus cosine squared theta. Everybody see where I got that? Just multiplied it out. If it's one of those patterns that you learned in Algebra 2. Now, what is sine squared plus cosine squared? That is 1 plus twice sine theta cosine theta. Does this look like anything you've seen before? What'd you say? It is the sine of 2 theta. And notice that is exactly what we wanted. So we're done. Okay. This is sine squared x over cosine squared x minus the sine squared. Okay, in this case, we want to add, we're adding or subtracting. What do we have to have if we add or subtract? Common denominator, which is going to be cosine squared x. So over here, I'm going to multiply sine squared by cosine squared over sine squared. Cosine squared over cosine squared. So that I can put everything over cosine squared. Okay? Did everybody see how I did that? I just got that common denominator. I multiplied sine squared times cosine squared over sine squared. Now, is there anything common to those two in the numerator? See anything you could factor out? Well, no, I can factor out a sine squared. And remember, when we factor out, the first one doesn't go away, it becomes a 1. That sine squared divided by sine squared is 1 minus cosine squared x, and this is still all over cosine squared. Let me move this up a little bit. What is 1 minus cosine squared? Okay, so we have sine squared x times sine squared x over cosine squared x. And what is sine squared times cosine squared? Tangent squared. And what was it that we wanted to find to prove that it was equal to? Sine squared x, tangent squared x. So we've just done that. And we probably, had we worked on the other side, we could probably get tangent squared x minus sine squared x. But notice what I had to do. If you're adding or subtracting and you've got denominators, you got to get a common denominator. You look for things that you can factor out, and then you're looking at your different identities. Do we have questions on this one? Okay, we're going to look at sine of 2x over the sine of x minus the cosine of 2x over the cosine of x equals the secant x. I want to prove that. So we start, somebody's hungry. We want to start on the most complicated side, so that at this time we're going to start on the left side. Now, can I rewrite the sine of 2x? What is the sine of 2x equal to? 2 sine x cosine x over the sine of x. And how can I rewrite cosine squared x? Any ways that I can rewrite cosine? That's supposed to be cosine of 2x. I'm so sorry. Let me see if I can. This should be a 2x. This will work better. How can I rewrite the cosine of 2x? Cosine squared x minus sine squared x over cosine of x. Okay, now notice here these cancel. So I'm just going to rewrite this. Twice the cosine of x minus cosine squared x minus sine squared x. Just rewrote it, just so it's neat and we know what we have. Move it up so you can see. What do I need when I'm adding or subtracting with fractions? Ross, what do I need there? I'm adding and subtracting fractions, so what do I have to have? If you were adding 1/2 and 1/3, what would you have to have? Like a common denominator?
Yes.
What would the common denominator have to be here? Cosine x. So I can rewrite this as twice the cosine squared x minus cosine squared x minus sine squared x over cosine x. Notice I'm keeping this in parentheses because I'm going to have to distribute that negative. If we put everything over cosine x, we're going to have 2 cosine squared x minus cosine squared x minus sine, plus sine squared. And what's 2 cosine squared minus cosine squared? What's 2 cosine squared minus 1 cosine squared? Cosine squared x plus sine squared x over cosine of x. What is cosine squared x plus sine squared x? 1 over cosine x. And what is 1 over cosine x? Secant x. Is that what we wanted to prove? Yes, it is. Let me come back here. So we just got there. Okay. There's some different techniques. Surely I don't hear food wrappers. Okay, in this case, one side's not any simpler than the other. What was the first thing I said we could do to start out with? If we don't know what else to do, what can you do? What should be one thing we should think about? Rewrite anything in terms of sine and cosine if we can. So can I rewrite secant in terms of sine or cosine? How do I rewrite the secant? 1 over cosine. So that's what I'm going to do. I'm going to do 1 over the cosine of t minus 1, and t times 1 over the cosine of t. Okay so far? All right. Here we're just doing some math skills, complex fractions. With a complex fraction, if I multiply the top and the bottom by the common denominator of the numerator and the denominator, it should help me out some. So I'm going to multiply the top by the cosine of t and the bottom by the cosine of t. Can you see where that came from? Because cosine t times 1 over cosine t is 1 minus the cosine of t. And here cosine t times 1 over cosine of t is 1. Notice we're where we wanted to be. Exactly where we needed to be. Not as many steps on this one. Okay, your assignment is on page 519. I'll have to look up the number. I'm not sure what number it is. But it's 1 through 9 odd, and 13 and 19. That's really not that many. These are due after spring break, but I wouldn't wait till after spring break to start on it. Seniors, I would highly recommend that next week we work on these in class so that you remember. And it's in RedWeb what assignment number it is. I don't remember what the assignment number is. All right, so this is your assignment. You got a few minutes. You can start on it.